Hi everyone, this is Judy Sandrock from MaxIQ Space. In these slides, I'm going to take you through workshop number 5, the High Altitude Balloon Project with NASA Goddard. What does this project entail? This is a voluntary project that you can participate in if you are already participating in the International Space Station launch of 2025. It's certainly not mandatory. So NASA Goddard Balloon Office, they launch every year from Fort Sumner in New Mexico. And here I have some screenshots of some maps of the USA and where Fort Sumner is in the middle of New Mexico. The launch is usually scheduled for the 15th of August, but this can move for up to a week into the future. What we're going to be doing is we're going to have multiple payloads very similar to our International Space Station project. So each school or institution will have one payload space, and those payloads comprise an extended core. This is a different core from the one we use on the International Space Station, and this core is on its way to you. The standard X chips, you can use the prototype boards, but please no wires at all, because we can't have anything shaking loose or interfering with the other payloads, and the data is to be saved to the SD card. MaxIQ Space provides power, launch, as well as payload return. So what are the next steps going to be? If you would like to participate, please let us know, and we will start inviting you to those NASA High Altitude Balloon Project workshops, as well as your ISS workshops. There are going to be other schools participating in this, apart from those on the ISS project. So these are going to be scheduled separately with a different cohort. We'd also like you to decide on which X chips you're going to use, as well as to begin coding. So what does the program look like? Here we can see in green are the workshops right now that I'm covering. From our side, we need to complete the paperwork for NASA for the High Altitude Balloon Project by the end of February. So we're going to start looking at running the workshops during March. You're going to need to send us your payloads during June of 2025 so that we can be ready for the August 15th launch. All the other workshops for the ISS program carry on as expected. That schedule has not changed. So thank you very much for watching this short version of the slides. Now what is going to follow is the much longer format of the two different workshops that were held to cover the topics for workshop 5. So welcome to workshop number 5. And in this workshop, we're actually going to be covering the NASA High Altitude Balloon Project that one can participate in as part of this program. And I'd really like to make sure that everybody realizes that this is very much an optional activity. So it's not mandatory that you participate in this project for your ISS project. Also, the thing is that if you find that maybe this year you haven't got the bandwidth to do it, there's always next year, because we do it every single year. With NASA, we have a number of institutions participating in the High Altitude Balloon Project. So it's optional. So what I'm going to do in this session is I'm going to explain a little bit more about the project. Bianca can also maybe share with us some details from his side. And then we have a schedule that we're going to go through for the High Altitude Balloon Project. We'll discuss some workshops that we'll do in parallel with these ISS workshops to prepare for that project. The hardware that's actually on its way to everybody right now, and then the timelines and the next steps. So the NASA Goddard Balloon Office launches a project from Fort Sumner in New Mexico every year, and they have a standing date that they use, which is 15th of August. And so it's usually a few days after that. Sometimes it can be as much as a week after that. It's very, very weather dependent where the prevailing winds are flying, temperatures, pressures, and things like that. So what it is, that's very much controlled ascent and descent. They fly gondolas, two very large gondolas, which are the size of a small motor vehicle. And unfortunately, Jim Gorman couldn't be with us today, but he's probably going to be at the workshop tomorrow, sharing their experience. He was there last year with his students. And interestingly enough, a few hours from now, his students were going to do a presentation for the NASA Goddard Balloon Office team on the results that they'd found from the launch last year. But unfortunately, that had to be postponed because everybody's being completely snowed in around NASA Wallops, where the Goddard team sit. And so they've had to postpone that because they just can't get anywhere right now. So it's from New Mexico. So closer to the time, we'll be discussing who actually wants to take the payloads with them, who wants to go with their students to participate in it. And there's a number of workshops that the NASA Goddard team take us through in preparation for that. So our next deadline from a MaxIQ space perspective, our next deadline is by the end of this month, February. We need to get our documentation in. It's a pretty easy process. We've done it a number of years in a row. There's a lot of paperwork that we need to go through. What we do is we submit that, and then there's a technical review that we need to go through, which we're very happy if you and your students want to be in the audience for that, because it's actually quite interesting to see the process that NASA goes through to get to make sure that we get approvals. So what is it? What it is it's very similar to the ISS rideshare, where we have multiple payloads stacked into one container. And what you'll see here on the top is the extended core, and it's slightly different from the one that you have for the International Space Station. And so those are on their way to you. So what I'm going to do is that I'm going to stop sharing, and I'm going to show you what that core looks like. So what I'm going to do is I'm just going to pin that so that everybody can see that on the recording. So what it is it has the ESP32, which we used to. It has the SD card interface over here. But what's really interesting is that this connector here is actually for an HD camera. So you're going to be able to fly an HD camera, which is really going to be quite interesting. And it's slightly longer than the one you have for the ISS, because we haven't got a space constraint when it comes to the high altitude balloon project. We don't have a space constraint or volume or a mass constraint, because our payloads are pale into insignificance when it comes to the size of the gondolas that they're flying. So yeah, our paperwork needs to be in by the end of this month. And what we're going to be doing is we're going to be including having our own GPS X chip, as well as approval for the cameras, the HD cameras. Last year, and Richard, Don, I'm sure you can attest to this, is that NASA did send us the GPS data, but it was very spotty. There were times where there was no data, and then there was some data, and it was quite a job to actually kind of synchronize the data on the SD card with that data that we received from them. So this time we're going to have our own data, our own GPS X chip, writing the data to the cards. Okay, so everybody in the US, your extended course, everybody's receiving two, so that you have a flight model and an engineering model. and it uses the standard X chips. So those were dispatched from Massachusetts yesterday on Monday. They were snowed in on Friday, so it couldn't be sent on Friday. But it's on its way to you. And for those in South Africa, definitely you'll be receiving those this week. And I'm going to contact Afriki and find out how we can get them to him in Cameroon. I do know that he's got a lot of X chips there with him. So I'm actually quite confident that he does have an extended core there with him. So what you can do is you can use the prototype boards. You can use all of the different prototype boards. I do urge you, though, please don't use up those special ISS prototype boards because we had limited numbers of those made. But I think you've all received these generic ones and these generic ones, etc. So you can use any of the prototype boards, and that core will run with all of the X chips, your standard X chips that you have. And it's the same process. You save the data to the SD card. One difference is, however, is that it's a slightly older version of the ESP32. It's not the ESP32 S3. So it's going to be slightly different from the code that's been developed for your ISS project. And then for the flight, we provide the power, the launch, the payload return. And so what you need to look after is writing your data to the SD card so that you can then recover the data from that SD card. At this point, Bianca, would you like to come in and say anything about this?
Yeah, so as Judy mentioned, I'll just keep that picture up you had there, Judy.
Okay.
Just keep sharing.
Right.
So just to clarify different things, you have the prototype board that Judy referred to here in the small picture on the screen is this thing here that has connectors on all sides. That's the one that you can use on this flight. The one that have like white lines on the side was those that was specifically made for the ISS. Just if you have the different boards. Now, we do recover this project here. It's of course full of dust and all that kind of stuff. So if you have one of the ISS payload and you want to test them and things like that, that's one of the options with this flight here. But just understand when you come back, you have to go through a little bit of a cleaning project. It's a dusty environment, flying high altitude from New Mexico. I think it lands in Arizona, so that doesn't help a lot. The reason why we haven't developed a new extended core, so we're using the old extended core for this. We have made a new one for the ISS mission, but not for this thing here. So the code is the same except the pin configuration for the SD card and the pin configuration for the I2C are different. So when you write your code and have to run it on this thing here, you have to refer to other pins. So just so you're aware of that. If you go to Domino 4 / capital letter CWV, then you will see the pin configuration of this version 4 core that we're talking about here. So, and the another thing is that, as Judy says, we don't have any limitation in space. We try to keep it inside, a standard configuration of a U, maybe 2U, whatever. But we do actually have more space. So we're going to use the spines that we're going to use for ISS, the same kind of connectivity and power and that kind of stuff. So what we're going to do is that new for this mission here is that we're going to be asked for permission to put a camera on. So if you want to experiment with that already, then if you go to dominofort.com, you land on our GitHub page. If you search for camera there, you will see a whole thing about how to use the camera. There's also a link to Amazon to buy the camera. They're like $11 or something like that. They're not like a fortune. And when you buy the camera, try and make sure you buy the one that have a longer cable. So they're very small. You can split that on off, Judy. So I have more video space here. So so this is the camera. It here, let's see here. So that records something like close to HD, and it has a little adhesive tape on the back. And then I have this 11 centimeter, 4 and a bit inches cable. You can find them that have like just like not even an inch cable that looks like something like that in length. And then it will just sit on top of, you can't really face it anywhere. So when you look for this thing here, I think it's on that website, it's called OV 2460. I can't remember it, so I'm not gonna. But if you go to that page that's called camera, I'm gonna put the link here when I'm finished talking in a chat. So there's a link to that, and then you can actually figure out how you want to use your camera. And the thing is that you can use it both for video and you can also use it for still pictures. The extended core have a PS RAM, and the main reason for the PS RAM is that you need like a frame buffer in order to record video. And when you take, for example, the example that I suggest you in that GitHub page, there's this example. And you just, when you program it, you say that you want to use a PS RAM, and then you can actually play around with it. So you can see how the code is. So maybe you want to snap a picture every, 1 to 5 minutes, whatever you kind of like feel like, if you want to take that. It might also be that you have another experiment on your prototype board, and you actually want to capture video of that. So consider not only just to look out the window, but also if you want to record if any of your prototype board have some kind of like experiment that, maybe change color or change look or whatever. The interesting about using a camera on these high altitude balloon is that when we fly an airplane, we fly up to 10, 12,000 meter, 10, 12 kilometer, up to that's 36,000 feet. But the balloon here goes like 3 times higher up, so it goes over 100,000 feet. And while we're far from space, we actually only like a third of the way to space. But if you look up at that altitude, it's black. So it feels very much like we're in space. So that's always interesting for students, that if you have a camera and you take a picture from that altitude, you can of course see the Earth and things like that if you have it sideways. And then it's clear to see how high it was up. Now, if you're here in the call tomorrow, where Tim Gorman hopefully is talking a little bit about theirs adventure last time, they got some very interesting data, and they of course have a number of theories about what the data, what result is in the data, and they might wanted to have a camera to kind of like take a picture of the different events, so they could like, this looks like that reason. So so that's a little bit about that. We still have to just make sure it's all right to have a camera on. I can tell you, if it's a satellite and you put a camera on, the process of getting that accepted is like double up in paperwork, because just having a satellite and radio and all that kind of stuff, that's easy. As soon as you put a camera on, then it's like surveillance. So it doesn't matter what kind of camera you have, they get a little bit difficult about it. So this is still NASA, so we just have to figure out what we can do there. The GPS, similar thing. It's a radio device, but I only receive your signals. I can't imagine there's any problems in that. So we're definitely going to try to make sure we can get the GPS on. And of course, if you want to do anything special on your prototype board, that's kind of like have a kind of like chemical connotation to it, we need to figure that out, because that kind of stuff needs to be separately handled. They're used to, of course, electronics, but if you run a little E. coli bacteria test up there, then I'm pretty sure they want to know that. Another thing we're going to try is that the last couple of times we provided power ourselves, and that's gone fine. We had power for the entire mission, but they're flying something like a Volkswagen in size, and the gondola. So they probably have plenty of power, and we don't need a lot. So one of the things is that I would like to piggyback on their power, especially because they tend to kind of like get ready, and then the power drains down a bit, and then they say, we're not flying anyhow, and then next time they fly. And if they do that too many times, then suddenly we don't have any power. Then forgot to change our thing. But if we are on the main power, then hopefully they're not going to fly without making sure they have that. So that's the kind of like 3 different things that's going to be different from this mission. We kind of like in the long run want to do a couple of other things, but we're not going to do that for this mission here. One of them is that we want to do our own radio, but that will also require that we probably follow the balloon to a certain degree on the ground. But that just could be interesting to kind of have live data. The other thing is that we're working with the university about gamma radiation detectors as an X-chip. So we are kind of like think that could be an interesting concept on that altitude, but that's not going to be ready for this. But that's just to give you an idea about some of the future missions for this thing here. Any questions?
Sorry, Bjarke, apologies for being a little bit late. I was just in a board meeting. I just want to check something with the camera. Is it a shared camera, or will there be a camera per slice? Sorry.
Camera per slice.
Okay, thank you.
So I'm just gonna find this link I talk about here with the camera. I have a feeling it's called camera. So let's see here.
I think Mike found it, and so did Alex.
Mike, did you find it? Yeah, okay, there it is. Thank Alex put it up there. So Alex, yeah, great. Thank you. So that's a camera thing. And I also just want to say, so there you will see how it works. It's an example that's there already. I'm just kind of like specifying this documentation, what pins to use, because of course there's a lot of different boards it supports. So how it supports for us. Now, if you want to really get dizzy with this stuff here, you can also use the camera for AI. So for example, you can train it to look at, let's say, different fruits. I had like an example where I trained it to look at chili, red onion, and bananas. And then you hold it off on the camera, and it will kind of like give you a percentage chance of whether it's the one or the third. And if you want to kind of like learn a little bit about that, I have another Domino page here. It's called AI. I just put the link in there, and then you can try play with that. I tell you, it's a little hairy, the process you have to go through. But so it's not like something you do in the afternoon. And you probably get your most tenacious students to kind of like look at it if they want to. But in reality, what it is that you do inference on the CWV. That means you do training in the cloud, and then once you've done the training, so there's a different kind of like websites that have like 1,000 pictures, the same thing, So I have here in my page here where I got my pictures from, so I downloaded 1,000 or 10,000 pictures of red onions and bananas and chilies, and then I uploaded to this other website that can do the training, And once it's done the training, it spits out an Arduino program that have the reference to all the different things. And you load that into your CWV with the camera, and then you run it. And I think I had it right out on an OLED or something like that, where it will tell whether it's the one or not, and the third thing. And it doesn't get it right all the time. But hey, it's an AI exercise using the X chip, so that's kind of like the reason why I'm into it. So that just, if you want to go down the route with AI a little bit further than just taking pictures of video. But I'm just saying, warning up front here, it's really hairy to go down this AI route.
Okay, so Bjarke,
yeah.
So Bjarke, what you're saying is that they can either use that core they're receiving for going through the clouds above New Mexico, or they could actually run some AI on another cloud.
So
from the clouds.
So exactly, that's nice catch. So you can use the computer cloud out there, the internet cloud, or you can use the meteorological cloud that we're using at high altitude. You could probably, even if you concentrate, use both, but I wouldn't go that far.
Yeah, what you could do is train it to recognize different clouds.
The only reason why I take this AI is just to give example of that, camera's interesting for other things than just, taking pictures. So yes. So each extended core, just to emphasize that, each extended core here, I have one here. So that's what you've been sent. So it has the old ESP32, and the big difference is that this is 4 megabyte. The new one, you have 8 megabyte, but this one here have the camera port on it. The one you use for ISS doesn't have the camera port because it had to be made smaller. It has the SD card on it. It's the older version of the SD card, but it works fine. And it have this extension port here that you don't need necessarily. But if you have anything that run SPI, you can connect it to that. And then I have the transceiver for CAN bus, and it have the PS RAM here. I normally think I hold like that, but that doesn't matter. So that's that. And then the camera you slot into this where it says camera here on that. So yeah, just interesting another sensor you can add to it. And the thing is that in reality, I think like 2/3 of all satellites in space have cameras on it. The schools, everybody tend to try to put a camera on anything they put up there because at least you can take a picture and download it. And what the future leans towards, especially with the revolution in AI that's happening, is that you do, instead of downloading pictures and video and then analyze them on the ground, you start getting into a situation where you're powerful enough that you can analyze the pictures and video on your satellite and just send down the result of it. So let's say, for example, you try to spot forest fire, then instead of sending pictures down and you have to look at the pictures and check the forest fire, maybe you get like a geofenced coordinate system of the forest fire according to this thing here. And then what you save on rate, you spend on computer power on the satellites. So just so you have a little idea about where we're going with this thing here. Okay.
Bjarke, sorry, may I ask another
question? Go for it.
Sorry, the orientation of the cameras, obviously on the payload, each camera would be pointing, would we select how it would be pointed, or
so good question. So it sits on this very flexible cable here. So the reason why I suggest that you get the one with the longer cable is that if it sits on this port here with this short cable, so normally it comes with a very short cable, it can only face, away from, it will lie on top of this chip here actually, and it can only face that way. And unfortunately, the chip is stacked on top of each other. So if you have one of those short ones that sit there, it just looks at the next layers back. Okay, so not very interesting. So by having this one here, you can then put it up so you can we can put it sideways up on the side or at the end of the boss. Okay, so you just open your picture you just had before. So what we're gonna do is that, so you can see if you can imagine we had underneath now there's a radio on that top version there, but you can see the ESP32 there lying in the background there. So if the cable is long enough, as you can see here, to go around, and we just put it at the end, and then we just put all the cameras, we just glue them on the inside. I mean, there's this little sticky tape here. Either that, or we 3D print like a frame that we hold them to, so they stick out that way. And the reason why we kind of like do it that way is because obviously this one here is sitting on a gondola with a lot of other equipment. So we can only kind of like only ask for like a window to the one of the sides. Okay, so we have, doesn't really matter for the measuring anything atmosphere because it comes in everywhere. But when we set the camera up, we're just gonna face them sideways, so they kind of like look out sideways. We could maybe also have them looking up, and we can figure. So that's the two options: sideways out of the gondola or looking up. There's no room for looking down because we sit on the top of the gondola. So but looking sideways is the normal. A lot of those who have putting cameras on these sides to balloon, they're like interesting in seeing, the horizon because it changes and you can see everything. Some like to put a camera on top so they can see when the balloon explode, but that's a very singular event, so that's not the same. But yeah. If you have any, by the way, if you have any requirement or wishes about how you want the camera, let me know and we can try to figure it out. It might end up there are very few cameras because people are not ready to program this or get that up and running. So, Richard, if you're the only one, you can really dictate how you want it, and then we can see if they're happy with it, Mesa. But I'm not sure there's going to be too many who's going to put camera on. Mike, Michael Galvin, I don't know if there's any mics here. Are you going to consider putting a camera on?
I doubt it. My students are pretty focused on the ISS payload, so anything we fly on the balloon is probably just going to be a clone of one of our ISS payloads, and so absent camera.
Yeah, cool. And his students probably, Richard, sorry to say, those who best qualified to get this thing working. So if he's not flying camera, you might be very close to be alone.
Yeah, I'm not sure. I just want to make sure that I can let the team know.
Absolutely.
I would obviously see this.
Also, Ahmed's there. She has, if you look there, she already got it because you are you gonna use Ahmed? You are gonna use that for the vomit comet?
Yes. But I want to see how you connect it one more time, if you don't mind, because when I have from the link that you have in a canvas, one of them, the little one, it was not available. So I bought the other one, which is this one. But when you try to put it in here, you can because this part right here is bigger than this part right here. So I want to see how you connect it and see if I need some kind of adapter or something.
Okay. So let me try here. So on the on this, let me do it like this thing instead here, so I don't have to try to hold the hand up and find the camera. Where are we? Finding. Here we go. There. We're out of focus. Come on. There we go. So I know it's slightly out of focus. Let's see if we can get it better here. But this is the camera port here. And the black one here, you flip that up. So that's now flipped up, okay? And then the camera you hold like, so you have the camera facing away, and on the other end, that thing here, you stick it in here, okay? And of course it comes a little bit out, but that's all right. And then you flip this arm down, okay? And that's it. That's how you put it on.
Okay,
And
so
if yours are wider, then you probably, if it's wider this way here, then you probably not have the right one. If it's wider this way, don't worry. This thing here is sitting, correct in. It doesn't go further in than that, but it goes correct. If you run the example you have there, you will notice it will complain if you can't see the camera. So the camera here uses I2C also, and like a lot of other pins. But
okay, that device that you have, that port for the camera, is that another port that I need to get? Because this is what I have. I don't see that port there.
No, but that's also the wrong thing you're holding up.
Okay.
Judy? Didn't she have? She haven't
Yes,
received it yet?
Amit, it's on its way to you. It's still on its way to you.
Okay. Oh,
that new call.
That's why. And I was like, when the camera arrived, I was
no.
That's... And I was like, okay, don't worry, we have a meeting.
Okay. So this is
still on its way to
this
you.
Is
okay.
This is the way. This is the old one here. You can see here there's the two cores. Okay, and trying to position this thing right there. We go. So you can see here that this one here is the one you have already, and that's for the IS. And this is the old one here. And the reason why we use the old one is because that have a camera port, because it's that bigger than the old one. Okay. So that's the reason why we have it like that. So the one you have for ISS doesn't have the camera port, and you're getting this thing here, as you said in the beginning, was shipped to you here like yesterday or today or something like that from Massachusetts. So you should have it soon. And then you have that port.
Since I'm going to be doing this for the zero-G fly, so we can use the same one and send it into the balloon. So not the first time we send some cameras on the balloon.
Okay,
so.
Cool.
Okay, are there any more questions for Bjarke?
I just
Can
want
I
to
ask
say,
a question? Yeah.
I just make a comments. Yeah, thank you so much. What another amazing opportunity from you guys. I'm really super excited. So, and it's a perfect opportunity for us to test what we want to fly on the ISS. So thank you, Judy. Thank you, Bjarke.
Of course, Richard. Absolutely.
Absolutely. Judy, can I punt something else with Amit here?
Yes. Yeah.
So Amit is flying on the zero-G flight. So the zero-G flight is the thing here that NASA flies to do astronaut training. So Amit asked if we have considered the medical field for our sensors. So there's been an upgrade in the starter kits. If you have one of these Bluetooth chest belt here to measure the heart rate, and you download the starter kit, and you put the chest belt on first, then you will actually be able to read your heart rate on your little device here. Okay, so it will record it to the SD card, it'll write it out on screen, and we'll put it on Kibana. So we did that upgrade because I wanted to kind of like try to read the Bluetooth sensors also. So Amit, I sent you the video. Have you got yourself a belt yet?
No, yeah. I was in the NASA
Okay.
conference last week, so I was
Yeah,
like,
that's right.
yeah.
Okay.
Well, Julie knows how this is.
I'm so jealous.
So
You should come next year to see. There's another one in June, Space Conference, which is in Kennedy Space Center. But the biggest one is SEEK. It is every February, first week of February.
Okay, so what I'm going to do now is I'm going to post a link to a YouTube video where I document all this thing. If you want to play it, try it yourself. So it should use any kind of heart rate monitor. I use this XOS because that was the cheapest thing I could find here locally. But it should be used for any Bluetooth heart rate monitor. And the reason why I also did it was because, adding a STEM field, like, for example, sports, that kind of stuff, you put that on, some of the sports people, they run around with a little GPS thing on the back of their shirts. But you with this thing here, that you can, of course, have a heart rate monitor like on your watch and things like that. But with this thing here, a mate will also, of course, fly and barometer and accelerometer and be able to kind of like check her heart rate compared to how the flight is performing. Is he going to, nearly faint when gravity suddenly disappears? And she will have the data aligned with each other because obviously she have the heart rate and the accelerometer next to each other. So we can measure what's happened with her and with her heart at the same time. And because it's writing on an SD card, it doesn't have to be online to the Kibana, but it's just another sensor. And once you get it and play with the video and things like that, let me know if there's something in the video that's unclear. But the rest of you guys, you can watch it. You can download it. It's ready because the starter kit have it built into it now. And if you're going to have a heart rate monitor, you wouldn't see any difference. So it's only when you have a heart rate monitor and you put it on first. These ones, the automatic turns on when you put it on. When you put them on, they turn on, and when you take them off, they turn off. So you put it on, wait a little, and then you reset your starter kits, and it will show a screen with a heart rate monitor, heart rate measurement.
Okay, great, Bjarke. Thanks for that. What I found really interesting about that application was that we've known for many years now that the ESP32 can also communicate using Bluetooth, and it's really nice now that we're starting to have an application for that, because very often maybe the Wi-Fi is too power hungry, or maybe we don't have access to a Wi-Fi, and so actually using Bluetooth communication with the different sensors could be great. Okay, so Alex is asking about the 3D printed holder for the X chips. Alex, Bjarke's actually developed a tool for designing the enclosures for different X chips. So Bjarke, what I was thinking is, before you demonstrate that, I'd like to go through everything with this workshop to make sure we covered everything that we need to cover, and then maybe if you wouldn't mind staying for a little bit afterwards to go through that, how to use that tool. And I also know that Mark Galvin has got some questions for you.
I'm here.
Okay, so if it's all right, I'd like to go back to that slide. This slide has made itself very famous today. So what are the next steps? What we will do is, as I mentioned, we need to get our paperwork in by end of February. And at that point, we're going to be able to schedule the next steps and the next workshops. And then, please decide on which X chips you want to use on the high altitude balloon project. And start beginning to begin coding. Last year, Jim Gorman and his students did some really interesting code. Richard and Don's students, Leanne's students at Parklands, they also adapted that code for theirs. So I'm sure they're going to be very happy to share that. And then if we have a look at the updated schedule, so on our shared Google Sheet, that's today and now, and then we're repeating this workshop again tomorrow. And as you can see here, what we will do is during March, we will have a project update in terms of the NASA High Altitude Balloon Project. You'll need to ship your kits to Max IQ Space during June, because what we need to do is we need to make sure that everything gets integrated, and then the scheduled launch is August 15th, in and around there. So whoever is going to go with their students to New Mexico takes all of the payloads for integration. And it's really great because the students are taken through safety workshops, how to integrate everything beforehand by the NASA team, go through a whole weather briefing the day before, what's expected with the flight, etc. So it's a really great practical experience for the students. And then what we do is we continue with our ISS payload finalizations, etc. And Voyager requires the payload 3 months before the launch. So here we're looking at, so you're going to be doing your high altitude balloon project in parallel. So please don't wait for the results of your high altitude balloon project for your ISS project, because that's probably going to be too late. You're going to need to find some other ways of testing those payloads for the ISS. So just in terms of Voyager, our launch provider, we've received the contract from them, the scope of work, etc. That has been approved on our side. It's going to be sent through. So I'm going to be able to share that with everybody, what the final scope of work is from them. And there are no surprises. It's as we expected it. The only thing that has changed is that we scheduled on that launch for October 2025. That is it for this workshop regarding the ISS and the introduction to the High Altitude Balloon Project. So I thought what we could do is we could go a little bit off topic from now. Before we go to 3D printing and design, Mike Galvin, I think you had some questions for Bianca, or is it not for sensitive viewers?
No, they're just super off topic and not relevant to anyone else. So I should probably save them till the end if Björk can wait.
Okay.
Okay, great. Does anybody else have any questions?
Sorry if I missed this. Each school getting one slice? Is each school getting only...
Yes. No. Every institution is getting one slice. And so, Richard, you and Alex and the foundation have a very special arrangement where you are sharing your payload for the ISS mission, but that is because we are extremely limited in terms of volume and mass for that mission. We don't have that restriction with the High Altitude Balloon Project. So Parklands can send one, Trinity can send one, the foundation can send one.
And play.
Yes, absolutely. I'm sure if you ask nicely, Bianca will allow you to do 2. And have to ask very nicely.
Very, very nice.
Okay. Any other questions?
Judy, if you can send me again the link to book a time with you, because there are some stuff that I need to fill out for the payload integration package for 0G. So, yeah.
Great. The link you have should work, because what I've did is that I made that just going 60 days into the future forever. So that'll work. Actually, for anybody who would like to have some time with me, what I'm going to do is in a separate email, I'll send you the link to my calendar. So I'll send that to everybody. But yeah, that'll work. Okay, Bianca, over to you. If you'd like to share your screen and take us through.
Okay.
I'll put the link.
So, yeah, great. So, Alex, we have this website that's called box.maxiq.space. And it's a tool where you can design, your kits. So I'm holding up here an example just so you can see what I have here. So here I have 6X chips. There's a screen here. There's a core with the SD card. There's a number of different sensors. And there is the USB here. So the first thing I go is I'm going to say I have three, sorry, where are we here? We are. So I have 3 in a Y direction and 2 X chips. And I click update, and you can see now I have a box that can fit those 6, okay? Then I start filling out what I have in a different boxes. So in the position number 3, I have the screen. So I can go down here and say display LED, and then I can say update. I can wait till I'm finished, but you can say, no, I'd put a window there. Then in position 4, I have a power USB here. And then I have in number 1 position, I have a weather sensor. So I'm saying sensor grill. And I also have that in number 2. So I also send sensor grill here. Okay. And then I say update. And then I made like a hole. You can see there's a hole down here in a box for this USB A. And there's the 2 grill and things like that. I can even put a text here where I say Trinity. Let's take this way. And then I can say in position 4. So I go here and say 4. So I can use it again. And I say text horizontally here and say update. And you can say, it now says Trinity in the corner. And then up here, you can say how thick you want your wall. The default, like I use a lot, is a 2 millimeter wall. Then there is a space millimeter, and that is the space between the, let me just move it a little bit around here. So I'm just waiting for Alex here. So the space,
there's me error messages, so I'm trying to just get a computer that'll work.
Okay. So you can see there is a little space here between the standoff and the wall, and that's just in case that you have a 3D printer that is maybe shrink stuff a little bit. You can set it to 0 if you have a very accurate 3D printer, or expand it. So that's this space here. Then the enclosure, that's the height of the enclosure. So the wall here. So you can take your project and measure the height of it so you have it the right height. And then the standoff is these ones here. They're standard 5 millimeter. You can make them 3 millimeter if you don't have anything interesting on the bottom side. And then there's like a lot of other things you can choose. There's something called SW7 because this is something that survived from other stuff. So there's a number of different things here that you can try to play with. Once you want to print it out, this is probably not the best way. you can go in and say 3D print ready, and the only thing it does, it faces the lid upside down. So when you print it out, it's kind of like printed out with the minimum requirement. But the best thing is say box and then update, and then down here you say generate STL, and then you say download STL like here. So I'm gonna say download and keep. So now I downloaded an STL file, and then you go back here and say lid and update, and then you can, download that separately, okay? And then let me just open this file here. So I'm just gonna say stop share and share something else. This one here. So this is then the STL file I downloaded. Okay, so I'm just using my previewer here to look at it. Okay, and back to is here. Yeah. So that's how it works, and it's should be quite straight out of the world here. So you do this update every time. You can also say you want to have rounded corners, so it's a little bit nicer. And then the most important thing is that if you, for example, have now taken a module like this thing here, and you need to fix it. Let's say, for example, there's a function here that's not there. I'll use a prototype board, or we haven't, made a variable. Let's say, for example, you want to put a hole here on the side, okay? What I then should suggest is you go to Tinkercad instead. And then let me just do Tinkercad here on my other screen here. Hang on a second. Share this one here. Okay. So I have Tinkercad running here. And if I say create a 3D design, so this is a free web-based.
We use it.
Okay, you use it. So,
yes.
I can absolutely just go in here and take my STL file. I just upload it or download it and import it. And then I can go in and put a hole in the side. You know how to do that. But,
yeah,
the STL file is comes up here. And what I normally do is that, if I want to put a hole in, I take this thing here and then, put a hole in a box somewhere. Okay.
Yeah.
That style. So, so you can always fix it, but you don't have to sit and mess all the screw holes and all that kind of stuff. So you have something like that you can start with, and then you can finish it in Tinkercad.
Awesome.
Did that answer?
Oh yeah, I just saw you holding it up before, and I'm like, oh wait, you've got to have a solution. I'm not going to reinvent the wheel if you've already got a way to do this.
No. So we had this thing here for a while. I use like small what you call this self cutting screws, what they're called, self-tabbing screws, small self-tabbing screws that I found on Amazon. You buy like there's like a bag of 500 of these small ones here. Right. So that's I use to just screw it in. But obviously, and then there's like a little tab system. So there's small tabs on the end piece here. See if you can see them. There's small tabs here. So you can click them in, and you can, of course, upgrade it however you want. So then click in, and it holds fine together like that.
Yeah. Awesome.
Cool.
Right, Bjarke, thank you. Alex posted that he got an error message.
It worked on my Mac, but didn't work on my PC. So it could be me.
No, so what you have to do is that I'd say some of these have an expired certificate. So you just go in and say you want to visit it anyhow. There's like, depending on what browser you have, They try to make it difficult for you to get to a
Oh yeah,
website like that.
my PC won't even let me do when I looked at the advanced, it won't even let me go to the continue anyway.
Okay.
So, but my
Okay.
Mac is letting me through, so I'm kind of curious.
Okay.
So,
Great.
Yeah, we have something we have to fix there.
Yeah.
yeah.
It would be so nice if these certificates expired annually, then it would be something we could put into the calendar. You know, suddenly it's, you know, we get inundated with these things. Great. Yep. Okay, so Alex, yes, now you've got something that you can use your 3D printers for.
Yes, my biggest challenge right now has been, all right, so we keep playing with the X chips and configuring, and then it's like, all right, they're just sitting there on the desk. I want to put our school store literally just bought these wonderful little battery packs. Find mine that are nice and thin and
yes.
and they even branded them for us. So
stunning.
So I want to get basically just like you have a little box, attach the two literally with Velcro, wire for power, and then I have a small pod that I can then just send with anybody on campus anywhere and let them, ruggedize, vibrate, since we're doing vibration and everything else. Just start playing with data sensing and how often should we collect and what does it look like, and as we go back and forth. So there's a lot that we're at the portability stage.
Great. Perfect. That's perfect.
So
okay, great. I can see everybody's needing to go. That's perfect. Bianca and Mike are going to stay on. Leanne, do you have anything you'd like us to cover or anything?
No, I'm good, thanks.
Fantastic. That's great. Amit, how are you doing?
I'm good. I'm sending you the email for the booking.
Okay,
Thank you
perfect.
so much.
Oh, wonderful. Thank you. Great.
Thank
Alex,
you.
anything else? Thank you so much. Thanks, Leanne. And Alex, anything else from your side?
Unless it's all top secret, I just like to sit and listen. And I'm going to continue playing with the little box. So
okay.
Yeah, I think we're just meeting with Michael regarding something completely different. So
we're talking about a different nano lab.
No problem.
Okay, see you, man.
I will see you probably.
You're welcome. You're welcome to listen in if you want.
It's fun, but I do have other things I should be doing. So,
Alex, maybe I'll see you tomorrow.
Yeah, probably more than likely. I'm trying to get. We're about to go on our 5-day ski break, is what they call it. So I'm trying to help sneak the kids out of class tomorrow afternoon at the end of the day, because I know most of them don't want to do anything.
Okay.
So it'll be a little bit more fun.
Fantastic.
Right.
Alex, thanks so much.
See you, Alex.
Thanks.
Ciao,
cheers.
bye.
Welcome, everybody, to the repeat of ISS Rideshare 2025 Workshop 5. And in this session, we are discussing the opportunity we have with the NASA High Altitude Balloon Project. And this is certainly not something that is mandatory, but it's very, very nice to have. As we go through the process, you'll see that there's a lot of ideas and experimentation for your students that maybe not that wouldn't necessarily be possible on the International Space Station. So it's a very nice complementary program. So what we're going to cover in this session today is we're going to have a look at the High Altitude Balloon Project, the schedule for it, the workshops Ifriki's also going to be able to share with you a little bit around that because he and his students went through the program last year and they participated last year in the high altitude balloon project. So we will be having some workshops in parallel with these workshops for those who are opting to participate in the high altitude balloon project. We are going to have other institutions joining with their students on that project alone. So we're going to have a new set. It's not purely a subset of this group. We have hardware which is on its way to you. It should have been in the US. It should have been with you on Friday, but due to lots of snow and challenges and school closures, etc., on the East Coast, unfortunately, it's only going to. I think it's going to get to you probably today or tomorrow. I must have a look. I think you all would have received tracking numbers.
My tracking number says tomorrow.
Okay, great. Okay, that's great. I must say that is the one really, really wonderful thing with Shopify, because we use Shopify to run our website. And so what I do is that I place 0 value orders for everybody, and then it generates a shipping label, and it's such a pleasure, that functionality. So yeah, they make no commission out of us because it's 0 value sales every time. But anyway, that's okay. After we've discussed the hardware, we're going to have a look at the timelines and the next steps. So what is this project about? Once a year, NASA Goddard on the East Coast, they actually are based at Wallops Flight Center in Virginia. And every single year, they have this project where they launch 2 gondolas, these massive gondolas, they're size of a small motor car, each of them. And they always launch from New Mexico. The schedule every single year is that they're going to launch on August 15th, but they don't really. They launch somewhere within a week from the 15th. So it's really important to keep that in mind when planning. So everything gets done so that they can meet that deadline of the 15th. But if the weather is not conducive and the conditions aren't conducive, then what they do is that they need to maybe delay a few days. So you can see I have 2 maps. The one, it's zoomed in a little bit. So the way you get there is you get to Albuquerque and then you drive east. That's the best way of getting there. And so it's in the middle of New Mexico where they take off, and they usually want to land in Arizona. So what it is that they're always looking for prevailing wind that is going to blow the payload towards the west so that they can recover it in Arizona. So it'll hang. The flight, can be anything from 8 hours to 24 hours. And so that's always what we need to consider in terms of our power budget. So Bianca's going to come in and give us a lot more detail. But here is a photograph of the rideshare that went last year. You can see the different institutions that participated. And so what we have is we have multiple payloads. We're expecting to have more this year. We'll probably have in the region of 18 to 20 payloads. And the extended core that's on its way to you, Bianca will show you the difference between that core and the one we're going to use on the ISS. It's a slightly different core. It has more functionality. You can use the standard X chips. You can use the prototype boards, but please, no loose wires that can. But there's a lot of vibration with this flight, So we don't want anything to come loose and maybe interfere with other payloads. And the same methodology as the ISS, we're saving the data on the SD card. Everything gets recovered and returned. And this time it is 100% recovery. And then you will receive your payloads back, analyze the data. So we provide the power, the launch, and the payload return with this. And so the next steps from my side are I'm going to start scheduling the workshops. What I'd like you to do is with your students is to decide on which X chips you want to use, and then to begin coding. There's a very nice coding example that was done last year by Jim Gorman and his students. Connor, I believe that your team with Declan, that you modified that code slightly. That was the one that you used last year and got those great results. Freaky, I remember we had a few challenges with yours. It wasn't saving the data to the SD card, but we'll fix that this time around. I was wondering, maybe I should hand over to you, Bianca, or do we have any questions before Bianca starts?
Just one real quick question. So we've done the NASA HASP flight as well. When we did ours, we had to go through the environmental chamber before the flight. Are our payloads going to go through that same process?
I think it depends very much on what's in those payloads. There's a lot of paperwork that we need to complete, and there's also there's technical meetings that we have with the team, etc. So maybe it was because maybe you had something particular there that required that additional testing, but not that I know of. Bianca, maybe you can assist with that. I don't know. I do know that you put everything through some tests.
Yeah. So the only test that we were required to do was that it can take I think it was like 2 or 4 kilo of load on the device, which kind of like for a test to see how strong the enclosure is. And so we've been doing that. The reason why there's not a lot of other tests that are required from us is because we only have electronics. There's no like chemistry or biological or anything else, and the batteries we're using are UL batteries. So they're quite happy with that. So we've gone through. We've been flying a couple of times before, and we haven't had any big thing with the paperwork. That might change this time around. I'm getting back to that. But from environmental thing, we did our testing, and then there was no problem with flying with our stuff. It could also be that we are limited in space, and therefore we pose very limited problem to the flight. Since there are other times we've been flying with a slightly oversized 1U box. So that's it. But let me kind of like go through it, and then maybe more accurate or other questions get raised. So Julie, if you can just take your second last slide and put it up again. The one with the container. So what we fly is, and the one that Julie has there on her slides, so the page before that one, that was no, you had the right slide. That one, thank you. That was the one we flew last year, I think. And the way it works, and it's very similar to the installation we have for the ISS. So there's these what we call spines. These you see that PCB with all the stickers on for the different projects that sit on both sides, and there's a light here, power, and another light. So for campus, and that kind of like provides power to the individual circuits and communication to the individual circuit. We don't use any of the campus stuff on the high altitude balloon flight because we don't have any downlink, so it doesn't really matter for that. But the whole idea with the NASA HAB flight here is that we are kind of testing before we go to the ISS, and that's kind of like also the reason why we want to do here. There's a lot of people when they fly that test their 1U satellites or whatever they satellite that send up, they do high altitude balloon flights because you get like near vacuum pressure, and you get wet different temperatures, and you also get some vibration and G-force when the balloon explodes. So what you have to do, what we provide is of course the spine and paperwork and all that kind of stuff. And what you're doing is that you're giving us a slide similar to, you can see here where there is the black MaxIQ's blank is there in the middle, and then there is 5 chips surrounding it. So what you have on the high altitude balloon flight is that you have room for 6 chips in total. So you can of course use our chips, you can use prototype chips that we talked about before, and we also have not the ISS prototype board, but there's these other prototype boards that very much look the same. They're just full lengths. They have connectors on all sides. The one you have with for ISS doesn't have connectors on all sides, and they have like a white line at the edge. So I mean, you could also use this in here if you want to. The core that we are flying with, and there's a reason for that. So I'm holding up I think just stop sharing so my picture get a little bit bigger for people who are looking. So we have these 2 cores here, and you can see that the one core is shorter than the other core, and it's also more narrow compared to the other one. And that's because this is the ISS core, and that's the one that have to fit inside this box. So the NanoRex lab we fly with for ISS, this one here have to fit inside because we don't have 10 by 10 by 10 centimeter, 10 by 10 by 20 to be accurate. We have the inside of this box here, which have like a 3mm wall, so something less. This thing here with the spine gets exactly 10 centimeter wide, and that's the reason why this is this size. Now, because we have to make this more narrow and things like that, you have to skip certain things away. So therefore, there is no camera port on this one. But there is a camera port on this one you fly with the high altitude balloon, and that sits here. And I don't know if it's getting sharp enough, but there's a camera port there and into my finger. And if you want to, so what we haven't flown with cameras before with this NASA HAB, and we're gonna talk to Haley from the NASA balloon office about you having cameras on board. So what we want to do is that we want to try to use this thing here. The only difference from the NASA from the ISS version to this one here is that the core is this core that sits on the ISS is ESP32S3, while this is just an ESP32, in module version. They both have PS RAM, they both have SD card, they both have the same power and everything else. But and they both have an extension port for example, SPI connectivity and things like that. But we haven't made this yet, so we fly with this core here. This is a version 4, and if you want to figure out what the difference is, then if you go to domino4.com/CWV capital letters, then you will find this in here. You can also go to domino4.com on GitHub and then look for CWV. And the old one here is called version 4, and the new one is called version 5, something like that. So it will say 5 plus on the website. The camera on this thing here, should you should we be allowed to fly with a camera, and should you choose to fly a camera, is a little camera that looks like this thing here. So, it fits inside my thumb here. And when you buy it on Amazon or whatever you buy them, find the one that have the longer flexible cable here. This is 11 centimeter long. They normally come with a much shorter one, but if you have the short one, it's going to be difficult to maybe face the, outside the box. Because if you have the short one, it's normally just as short so you can stick on the back of this thing here. And that, of course, going to look straight up to the next layer, which is quite uninteresting. So see if you can find a bigger one. They're like somewhere between $10 and $20. They're not expensive. And you click it in, and then you have a camera option. If you choose to do that, of course, you have some programming to do. And there is an repository on GitHub that's called something camera. So if you go to the GitHub I talked about before, I think Alex, you put a link last time in the chat. So I can see here there's a number of different comments here in the chat. Let me just see if we have it there. So yeah, Julie, you put the one link in there. Alex is going to find the link for the camera. So it will show how to use the camera on this device here, what pin you have to configure and things like that. There's an example in Arduino, and what this repository is showing is just how to get that example to work with that specific code here. And then, of course, that allows you to then record video. So that's the reason this one had PSRAM on, and that's also documented in that link. So if you and you need the PSRAM because you need a frame buffer for recording video. And then you have you can of course take pictures and things like that, store it on the SD cards, and then you have some documentation for your flight. And you can if you want to fly with the camera, there's probably very few who want to fly with the camera and get that to work. But if you want to do it, then let us know where you want the camera to point, then we will make an arrangement so it can point. The camera has a little self-adhesive sticker on the back, so we can just put it at the end of the spine so it can face out, which is the normal way, is that face towards the horizon. Otherwise, it can also face up, so it can maybe see the underbelly of the balloon, but we can't have it facing down because we're sitting on the top of the gondola, so we don't have a view to down. And I also think that if we have to do anything balloon, they're probably mostly nervous that we are looking down on the Earth. That don't really mind if you look at the horizon and looking up. There's not really any sequence up there. So that's the balloon, and I see you found it. Thanks, Alex. And Alex also put in the camera he ordered, so it's there. And also, if you're playing around with this thing here, and this has nothing to do with the balloon flight or anything like that, but I also put in a repository about using the camera for AI. And it's called github.com/domino4com/AI. So not CWV camera, just /AI. And that's a hectic little exercise where you can train it to, for example, look at different things. Like I did a model where I trained it to look at chilies and bananas and onion or something like that. And training means it's kind of like machine learning more than it's AI, is that there's a website that have pictures of different things. So you download 1,000 pictures of whatever, like onion, and another 1,000 pictures of chili, and 1,000 pictures of bananas, and then you feed that into a website that does training a model and then trains it, and then it generates the Arduino program that you then download and program your device, and it will then pop out on the your OLED screen, how likely it is that it sees one of the three different things. So for a learning opportunity in AI, you can use the camera for that also. But again, nothing to do with the flight, but just so you can kind of like maybe take that into the consideration. The whole idea is that a lot of satellites that fly today, like I think it's like 2/3 of all satellites have some kind of camera on it, taking pictures, and then they use quite a lot of bandwidth on downloading the footage. And what the future is going to be more like is what we call edge inference, where it means that instead of you download the picture, you analyze the picture on a satellite and you send the solution down. So for example, if you have a satellite that's looking for forest fires, then instead of sending pictures down and you have to look at and find the forest fires, you're using AI to analyze on the satellite and you just send like a geofence down and say, this is go here, there's forest fire here. So much less bandwidth when you send it down, much more use of computer power on the satellites. Anyhow, so that's the one thing. Another thing we're gonna see if we can figure out, and it's not a train smash, but it could just be interesting, was that we have provided our own power so far. So we've done anything from power banks to 18650 batteries. But what we want to do is see if we can actually connect to the gondola's power. And the reason for that is that when they fly these high-altitude balloons, they aim at flying the 15th of August, but weather dependent. So they might take it out the next day and get ready and the whole thing, and pull all the remove before flights and power up everything, and then they don't fly anyhow, and then back into the garage, and then next day they do it again. And for every independent power solution there is, then maybe have to recharge it, and we just thought if it can be on the main power, then they don't have to do anything for us. They just recharge their own batteries. We don't use a lot, but if you have to provide our own power, then it's always like another risk element that we want to avoid. The last thing we're going to do is that we're having our own project flying, and in our own project we're going to have a TPS. So we're going to record the TPS of how we're flying, and that's just going to be synchronized with powered up at the same time as your own project is powered up. So we're going to have that, and we're going to share that with you, so you can then in post take your SD card data set, and you can then mix in with our GPS data set. So if you want to position and how we fly over ground and direction and things like that, then you altitude, those kind of things, then you can mix that in. So we're going to do that as well. We might what we don't have ready for this time here is, and I'm just saying it because that's one of our hope for the next flight, is that we're working with the university about a gamma radiation sensor, which can be interesting when you fly up in high altitude, and of course that can be interesting maybe even on ISS and other places. So it's going to be the same size as any X chip. They have just have a gamma radiation sensor on it, but it's not going to be ready for something for this flight here. But that's some of the stuff that we want to play with in the future. The reason for the camera is that, as Judy says, he wished that Jim Gorman was here. He flew last time, and they actually have been presenting and written papers on what they did on the last flight. And especially the NASA balloon office are very interesting to kind of see the presentation from the students there. And one of the things is that they kind of can't really figure out if they picked up something from a volcano from Alaska, because they were in weather data that found that salt from the volcano actually came over Arizona at the same time, but I also believe there's some military bases that also give the same. They had like a lot of sensors for gas that used on that altitude. So they have like some other ideas with that certain military aircraft that produce this gas here. So, but if they had like a camera, maybe they'll be able to actually see some of the sources for this thing here. Is, the aircraft flying past, or they can see like a trail of smoke that looks like something that comes from a volcano. So that's the reason why we want to do that. The other thing is also, when you fly in a commercial aircraft, you fly 10,000 meters, 30,000 feet, or slightly higher. At that altitude, you look out the window, it's just still blue sky and, clouds and things like that. When you go to what a high altitude balloon do, which is 30,000 meters, 100,000, 120,000 feet, it's still like only a third of the way, or less than a third of the way to space. But at that altitude, when you look up, the sky is black. So for a lot of students, it'll be like you have a camera and take a picture of that. Yeah, I'll be in space. So it's just slightly different kind of like feeling to it when you kind of like have your project flying on something where the sky is dark above you in daylight. So that makes it interesting also. Judy, did I miss anything?
Bjarke, I think that's covered it for now. I was interested, Mike. Are you able to share what the payload was with your students when you flew on that high altitude balloon project?
Yeah, so we have a flight termination device that we use to end our balloon flights. Essentially, it cuts a piece of string to separate us from the balloon. And we're trying to go through the process of getting it NASA certified to show reliability. So we flew 8 of them on the HASP flight, and 4 of them were triggered remotely by us on the ground, and then 4 of them were on timers. So we have a 5-hour timer that if we lose communications with our balloon, it'll terminate the flight automatically. So basically, every hour on the flight, we were either triggering one manually or triggering one via timer.
Oh.
And then what I was saying earlier is for that, we had to go to Palestine, Texas ahead of time, and they put all of our hardware. Actually, it was everybody that was on the flight had to go down with their hardware, and it went into an environmental chamber. So they brought the pressure down to 100,000 feet, and they brought the temperature down to, I think it was negative 80 C, really cold. And then they repeat the process, except they make it really hot. They bring it up to, I think it was 60 C, which is where most people fail, is heat under vacuum. But you had to survive an hour at 60 C under vacuum and make sure your electronics would survive. So that is a really cool process, though. You're right. It's as close as you can come to getting to space. 99.9% of the atmosphere is going to be underneath you at that altitude. Yes. So it's, for all intents and purposes, even though you're only a third of the way, the environment is nearly identical to the orbital environment. If your stuff can survive that, it would probably survive in space. So.
Yeah. Yeah, so we haven't, I can promise you, didn't have to go through any of that kind of stuff. We simply just have to prove that we could do the load test, 4 kilo load test on our device. And then we brought it there on the flight day or 2 days before flight. And then there was some engineers that just screwed it into the top of the gondola. We made it so it could be screwed into the plywood on top of the gondola. So, but we didn't, there's a number of the different that flies on the gondola that let go of stuff. So when the balloon flies, they drop stuff off from the gondola. So you can imagine, when you do some kind of like stuff that's a little bit different like that, or especially if you have any kind of mechanical solution on board, and I said, like anything that have any kind of chemical solution on board, then I can understand we have to go through all that. But we didn't have to do anything like degassing or thermocycling or anything like that. So we just flew this thing you saw, and when we flew here last August, we had power the whole way. So we had we had everybody had data on the SD cards for the entire flight. So so we survived both the cold and the vacuum and the heat and everything. So yeah, that was fine.
Yeah, I will say as far as the launch, they don't tolerate any surface winds. I think our launch got delayed 3 weeks, so it can
Yeah.
be a long time. So
Yeah,
yeah, if
I
you
think
can run off of their power, that would be. We were there, so we had a team down there that could swap out our batteries every time we got scrubbed. But yeah, that
Yeah.
is definitely a real concern.
Yeah, so we had in both both the last 2 years, whoever we had down there had to leave after a couple of days, and I think the 2 years ago it was delayed like nearly a week, and this last one was delayed I think 2 weeks. So nobody could stay there that long with students and everything. But they were very happy to kind of like take over and just make sure our stuff was working for the flight. So it's not there wasn't super complicated what we're doing with our technology here. It's more giving people a chance to actually fly something on the HAB, especially for those schools and students that haven't flown before.
Yeah, absolutely. And also last year, on August 15th, they actually took the balloon out. It was rolled out. They were actually starting to inflate, and the wind changed a lot earlier than they expected it to. So they had to abort that exercise. But the students were still able to witness that, actually how big the balloon is and all of that kind of thing. So at least they knew what it was like. It wasn't, a total delay for them. So it was still a really great experience for them. Yeah, Mike, and it's interesting what you say. I think maybe also because you wanted to get NASA accreditation for your equipment. That's probably also why you needed to go through that thermocycling and and those tests. Our X-Chips went through that process in 2019 when our chips were used on the ThinSat program. So they were used in the ThinSats, which were then tested and integrated at Morehead State University in Eastern Kentucky. And there they definitely had to put them through that process there. So, we were confident that they would survive. Yeah.
Yeah. And I've just shared a picture in the chat. That's from one of our high altitude balloon flights during the eclipse back in, and that's about 85,000 feet. So the view it's pretty impressive.
That is beautiful. So that is during an eclipse.
Yeah, I mean the picture was taken before the start of the eclipse.
Yes.
Yeah. Honestly, pictures you can take of the eclipse at altitude don't look any different than that. The sun is it's too bright. It kind of looks the same. But we do have pictures of the moon shadow coming across the ground, which is pretty cool.
Beautiful. Amazing.
Can you please just Susan is asking here about going to the launch site and whether it's live streamed.
Oh, okay. Susan, absolutely, you can go to Fort Sumner and we arrange that. We need to, so over the next few months, we'll just need to know if you want to go and who's going to be going along so we can get all of that paperwork done for you. But definitely that is something, and it's a fantastic trip for you and your students. I'm not sure about the live streaming. I need to find out. We haven't live streamed ourselves, but let's actually see if the NASA team do a live stream there. Amit, welcome. Nice to see you today. And Alex is saying we need to recruit a local school so that there is someone who can live stream it and pick it pick up all
Oh
our
yeah.
gear.
But
Yeah,
I
so
think they are my experience with the people for the balloon office is that at least for Cubes in Space put the live stream. And I think that we're gonna fly in the same balloon. Your
yes,
project and
it's
Cubes
the
in
same
Space.
project. Yes,
Because
it's
it's
the
the
same
same mission.
project. Yeah.
August 15, more or less mid-August.
Yes, because I
They have a
remember.
live
Yeah.
stream.
Okay.
They have a live stream,
Okay.
but I would love to be there in person because it's going to be my only time that I'm going to have a Max IQ and Cubes in Space project flying the same balloon.
That's
So I would love to be there.
Absolutely. Yeah, absolutely.
Definitely.
Yeah. So Alex, the way it works is that the NASA team, they recover everything and then they ship it back to us from Fort Sumner. So that's how we've received it in the past. What we do is we give them a box to load everything into with a shipping label, and then they ship it from USPS in Fort Sumner back to us. Whoever is going to be taking responsibility for receiving that. And yeah, the box also has a lot of sand and dust in it when it arrives back. So it's not a pretty sight. Be careful when you open it.
I was just figuring with all the different people that like covering the Boca Chica launch and everything else, this is a great way for them to kind of expand their influence, show up, live stream our thing, get a whole lot of press for it, and then they sort of participate. I don't know, it's just fun thoughts off the top of my head.
Absolutely. That's a great idea. Yeah, that's a really great idea. Let's look into all of those sorts of things. Yeah, we've still got time.
I was going to say, I know we have some kids, they were wondering the same thing. They're very interested in going to the launch site. I'm interested in going to the launch site. I know it might be a couple of days or potentially a week or 2 weeks. I'll just throw this out there. I am an influencer. I do outdoor adventure. I have an outdoor adventure channel and I have the video equipment to do the videography. So if I do end up going, then I'm more than happy to share that.
We just speak and it appears into existence.
I haven't done a space thing yet, but most of it is like camping and fishing and things like that, hiking. But this would be a new adventure. So
yeah, well, there's quite a lot to see in the area. Apparently, there's the White Sands. There's a number of reserves. You can go to visit Roswell, like kind of thing, buy an alien fluffy toy from a gift store, gift shop, that kind of thing. So yeah, so Susan, I'm gonna be getting to the deadlines. We're gonna look at the dates in the next few minutes. So is it okay if I just share my screen again? Mike, thank you once again for that photograph. Really spectacular. Oh, we really want to have more of those. So here we go. This is our shared Google Sheet with the schedule. So these ones in green are the ones of today and yesterday. So what we need to do from our side at MaxIQ is that we need to have our paperwork in with NASA Goddard by the end of February, and that's going to be fine. We have at that point, then they begin scheduling the technical meetings with us, etc. And what we will do is we'll also share those dates with you and your students so that you can be in the audience and you can actually go through that process. It's a really, really technical process, but it's absolutely fascinating. And what I am going to be doing is that I'm going to be sharing with you that template, that form that we need to fill in, and it runs to many, many, many pages, and you can actually see, what they're looking for, etc. So for the students. I feel it would be very interesting for the students to go through. So we will begin having those workshops for the high altitude balloon project during March. So I'm going to start scheduling those. We've got the call out for institutions to sign up for this project. And then we're going to start looking from March onwards, a number of workshops. It's not many workshops that we need to have with this. What we'll do is we'll have an onboarding workshop and followed by another 2 workshops. It's not as intensive as this International Space Station session. And then we need to have the kits shipped to us round about in June, because what we need is we need July for doing our own testing, integrating everything, getting it to whoever is going to be taking it to Fort Sumner for August 15th. So for those of you who know you're going to be going, please put your hands up so that you can also be the courier and the integrator and the hammering and screwing it and bolting it onto the gondola, which will be really great. Your students will be able to do that. And then, so what we'll do is we'll have a follow-up workshop after those payloads are returned. Then late August, maybe even early September, we'll have a follow-up workshop. What did you find with your data, etc. Then our ISS schedule is continuing in parallel to that. We are not going to be able to wait to get the results of our high altitude balloon project to inform our ISS project. This is very much something that you're going to be doing in parallel. And what's also nice about it is that there's a number of sensors that you wouldn't use on the International Space Station that are going to be very useful on the high altitude balloon. So yeah, everyone's going. Bianca, Ifiki, maybe we also have to go. But I don't know if we'll be allowed in because we're from away. So so we continue with our ISS project in parallel, and because the one thing that the ISS project gives us is access to microgravity, and that is one thing that we really can leverage for that. We don't have many constraints in terms of mass or volume with this high altitude balloon project. So this is where you can, stretch the limits a little bit because we're very, very constrained when it comes to the ISS project. So yeah, we continue. All the paperwork is being done with Voyager for our ISS project. So we're on track for that. We're on track for October, and that is going to happen. Great. And so that is the end of my slides. Yeah. Are there any questions or comments?
So just to clarify, for the ISS payloads working back, you had 3 months before the launch. Does that mean you have to have our ISS payloads by June or by July?
We're looking at, let me go back to that.
The way I was calculating is the HAB payloads are June, the ISS payloads are July.
Mark, I'm sorry. It's seems to be too late in the evening for me. My brain's a bit fried. Everybody in the US is experiencing so much cold, and we've got a heat wave. And not only that, but we've also got like like biblical levels of mosquitoes, you know. I don't know what's happened. They're all very tired right now. Yes. So with the flight being in October, and we need the payloads 3 months before, that gives us September, August, July. Yes.
So is that, but
During
is that July?
July.
Right.
July.
So
Yeah.
it says, Voyager needs them 3 months ahead of time. Does that mean we need to get them to you before that to give you enough time to get them off to Voyager?
They've in our latest conversations with them, and also when we finalized the paperwork, it's looking very much more like 8 weeks from their side. So I've kept this 3 months there because yes, we do need to receive them. And as we get closer to the stage, what's probably going to happen is that process is going to happen at Princeton with Mike Galvin and his team. So, so yeah, we want to play it safe by keeping that 3 months there. Yeah.
All right, just for fun, I did a quick Google search for Fort Sumner, New Mexico. If we're gonna all end up converging there, there's only 2 hotels, and I'm assuming the NASA people will take over at least one of them. So we'll have to be careful, or people are gonna have to be camping out.
Yeah, there's
Yes, and
not
also,
much in Fort
yeah.
Sumner.
Yeah, there's not much there. I certainly know that when William went, William Edmondson went, he went 1 year and he ended up driving for about an hour or so each day to get there. The same with Jim Gorman when he went with his students last year. Also, apparently, those establishments in Fort Sumner are not great. Anyway,
I wasn't going to comment on how good they are. Everybody could look when the high-end hotel, I believe, is a Super 8.
Yeah.
So,
Yeah.
yeah,
But you'd be
William
close.
said he would have been happier to sleep in the car than in one of those hotels.
The other fun thing is that it is the final resting place of Billy the Kid. So there is a whole memorial
Wow.
there. So when you're looking to make the tour, I was thinking of having one of the like STEM study tour companies put together a little package and see what they could come up with. But I'm looking and I'm like, yeah, we'd be driving for a day to get to somewhere else. But
Yeah, I think there's one restaurant. There's also multiple final resting places of Billy the Kid, so you can take that with a grain of salt as if that's the real
yeah,
one.
but I mean the fact that it's on Google sitting here and that was the one thing that came up was kind of just that was the icing on the cake.
Yeah, it's for some people, like when you go to a NASA center, it's a little disheartening because they've been around since like the 1950s and they really haven't changed much. They're not the high tech,
Oh,
pristine, clean establishments you might think to expect.
there's a
But
great
come on, I have been in Wallops. It's not so bad.
yes,
Yeah,
but I found the website for this. I'll put it in the chat. They show you all the buildings, and
Yeah.
it's fairly interesting.
yeah.
Oh, thank you. That looks great. That looks great. But I think that, yeah, what we need to do is we need to arrange with Jim and his students that they give us kind of like a how-to guide, how to survive and thrive in Fort Sumner.
And for the ISS, the Falcon crew, that's a Falcon cargo launch, right?
Yes.
So that'd be any place on the Space Coast in Florida, and we'll be having a launch party on our campus because you can see the launches from our campus.
Yes.
They're not close, but you'll see one because the chances of us getting tickets to get in real close are slim. So anybody who makes it and wants to make a trip out of it, I'll carve out some time and have the launch party for whatever day the launch is. If we can't get tickets to actually go see it.
But you
And
can see
then,
it from Cocoa Beach
yeah,
or from a Hyatt in Titusville. They have the roof, and you can
Mhm.
see it from the roof.
Oh yeah, there's believe me, there's lots of places to just
Yeah.
drive up and see it.
Yeah.
But given the number of kids and what we want to do, we're doing. And you see the flames and you see the booster separate, and it's a blast. And the closer you are, the more interesting it is. But this way, if we can't get closer, it rains, we're still good. I can still do a whole display with the launch feeds and everything else. So we will be doing that up big for once we know the actual dates in October.
Yeah. Alex, that's
So
fantastic. Yes.
we'll-
Thank you
we're
so
happy to
much. And
host.
thank you. And thank you for hosting Wendy Fillion from our Western Cape government. Because she said that when she was there at Trinity, there was a launch, and they could see it from your school. So yeah, thank you so much for hosting
That was
them.
I
That was
try
very
every
special for them.
Yeah, I pay attention to every launch that goes on, and if we're in the middle of a meeting, I will stop the meeting and for people who've never gotten to see one. Sometimes we're
Of
lucky,
course.
and sometimes the clouds cover, but a lot of times they don't. So,
Oh, it's fantastic.
and the best
Great.
part is going to be right out our boardroom, our brand new boardroom with all of our fancy stuff. So, like, absolutely, we're going to have pictures and all kinds of stuff ready to go for that. Because with our luck, it's going to be a 2 a.m. Cargo launch or something, where I'm sure we could all drive out to wherever it's going to, to get closer, but not sure anybody wants to be out on the out on the streets at 2 a.m.
Yeah. Yeah, absolutely. And I was actually thinking about it yesterday. We need to start thinking about mission patches, because we need to start designing mission patches and having them made and that kind of thing. I have found a really good supplier that does the embroidered mission patches, so that could be quite nice. And then of course we need to have a lot of swag made with coasters and stickers and pins and banners and flags and all sorts. Each of our payload has a mission patch.
I've had kids working on something fun for us. I'll share in a second as I find it again. So we have here, I'll share my screen. I've got a second one, but we have a funky logo that is a circuit board, wrenches, a game controller, and everything for all of our techno stuff.
Yes.
So we had superimposed the South African flag over it to designate our partnerships with Parkland and everything else.
And Saki Kamva, yes.
Yes. So that's one of them.
Yes.
That's one of the designs. Then there's another one. Hang on. Here's the original. So this one's the flag horizontal, the other one's the flag vertical.
Yes. And thank you for having the red on top.
Yeah, that's
because there's a number of people who think that the blue should be on top, but then they're flying the flag upside down, and you know what that's like.
Oh, believe me, I made sure that we're trying to follow. The goal was proper flag etiquette, so I made sure we laid out the flags the right way. So that's one. Where's the other? Yeah, where's the other?
You do know we can see your inbox.
Yes, but this is just a search for the student who sends me the stuff.
That's okay.
So that's the two.
Yeah, that's fantastic.
The problem is the white lines on your flag because they just come out. But so we're playing with that as a fun part of a patch, because trying to put the Parklands, the Saki Kanva, and our logos on a patch becomes a little busy. So Connor, you're the first one from your group to see it, I think. So you can tell us that you hate it if you want.
No, I think it's very cool. Yeah, no, I really like that. I'll let my team know about it. I
Yeah.
think
Well,
we'll
beautiful people, I
also
have to go because my kiddos are there.
Cheers.
Yeah.
Cheers, Amy.
But thank you
Cheers.
so much, Judy. I book with you. I'm sending you a
Great.
message
Thank
later.
you. Thank you.
Bye.
Thanks. Cheers.
Yeah, here's what this is our logo normally. So it's circuit board, wrenches, spot for
Very cool.
team numbers and everything, and game controller for all of our different activities. So
Very cool.
Yes.
our school logo is a fleur-de-lis.
Yes.
So that's our
Okay. Yes.
Very
I
cool.
see those, the wrenches. Yes. Yes. Okay. Okay. Yeah. And the game controller. Yes. Without the colors of the flag, that makes a lot of sense.
Yeah.
Okay.
Yeah, I'll chat to my team. I'll see. I know we've been working on a few designs for our stuff, so I'll get back with them, and once we have some finalized designs, we'll show you guys those as well.
Yeah, see,
Okay.
that's these are
yes.
our team jerseys. So that's our school logo.
Okay. Yes.
And that's the
Yes.
what I call the geek logo.
Yes.
And then
that's great.
And then we superimpose the flag, because we would try that and be fun. But
I have uploaded
Yeah.
5 pictures from the last flights. Just a little selection in the chat. So you can see the crane that lift the gondola up. You can see one of the pictures is there's Max IQ with our payload on. There's Bridget who's actually mounting it. So Gorman had a couple of students with, and there was actually students that actually mounted the payload to the gondola. So just a little, kind of like a few pictures, so you're having an idea about what it looks like.
I'm not seeing them. Is anybody else seeing them? I'm not seeing them.
I'm not seeing them either.
Okay, well, maybe now.
No. Wait, something's happening.
First one, first one came through.
Something's happening now. Yeah, okay. Yes, here we go. Yeah, there we go. Yes.
Okay.
It's the gondola. Yes.
So you can see it's a pretty big thing to fly. It's like a box there. There's like 2 meter high, and probably nearly 2 by 2 by 2 or something like that. So that's what they fly, and you can see there is I don't know if they're same order on yours, but there's a couple of guys on the top picture that busy working on a gondola. On the second picture, you can see our payload that's been mounted, the white box with a Max IQ. And then you can see Bridget on the third picture working on that box there. And then the last 2 pictures is the crane that lift up the gondola. This happens 3 o'clock in the morning. So, which explains the darkness. But I just thought, just so you have an idea, you can, spot some of the background in the building and things like that. So there's people working around in these kind of like old garages to get this thing here right. Our project that, we had this white box that was like slightly wider. And so the whole thing is that in order to deal with the cold weather, the batteries are protected in a separate container, and the X-tips are in layers, but open on all sides, as you can see with Bridget's the one Bridget's working on. She's in the yellow vest there. So atmosphere can get to the chips to all sides, but the power is insulated in order to make sure that it lasts the whole flight. But we kind of like hope we can get away with that with connecting to them directly. So just so you have a little inspiration to how it's more or less going to look like.
Great. Thank you, everyone.
Oh yeah,
I think we've
sorry,
really...
just one more thing.
Yeah.
Sorry, Judy. So there is the requirements for PPE, personal protection equipment, helmet and vest and glasses and all that kind of stuff. And Jim found it a little silly because he arrived there and equipped all his students with the whole thing, and they were the only thing wearing anything. I mean, the guys with the crane are wearing hard hat, but inside the place there, as you can see, some of the other guys are just standing there in the t-shirts and wearing nothing. So there's a high requirement, but once you're there, then it seems to be very relaxed. And the thing is that it's still important that we kind of like keep the high requirement, because it's a learning experience to be in an environment like that where you actually have to just make sure you have the PPE. Okay, sorry, Judy.
No, it's fine. Connor, PPE is personal protection equipment. Okay. Yeah, so we've gone quite a bit over time, so I'm concerned about keeping people way beyond a time allocation. So do we have any more questions or comments before we close out for this session? Okay, everyone's good. I think we're all excited. We've got a lot of nice, exciting projects all the way up to November, December. So a wonderful year we're having this year. Great. And Alex, thank you for sharing all of that. And Mike, also for sharing the experience that you've had with your students and all of that. And Amanda, it'll be nice if we could catch up at some stage. You have that link to my calendar, so please, anytime, just book me, okay? It'll be nice. Great. Connor, say hello to everybody from me. Okay.
Will do.
Okay, fantastic. Thank you, everyone. I want to close off.
Thank you very much.
For now. Thanks. Okay. Thanks,
Thank you.
Susan.
Hi, you're welcome. Take care.
Thanks. Cheers. Bye. Bye now.